Welcome back, my mathematical minions. Well, it's been a while, but as we turn around and as we're getting into the beginning of this unit on exponential, we need to talk about some sequences first of all. Now, I know we've talked about sequences. We've looked at arithmetic and geometric sequences already. But let's just review and let me show you a couple of shortcuts and some new ideas that we haven't talked about before. So first of all, an arithmetic sequence. This is, if you remember, this is some sort of repeated addition. Okay, so an arithmetic sequence is one that is repeated addition. Now, I know some of you guys are thinking already, what can it be? Repeated subtraction? Well, yes, technically, subtraction is just adding a negative number. So it's repeated addition or subtraction, but the definition is repeated addition. Now, in an arithmetic sequence, when we start to look at these, we know that an arithmetic sequence has a common difference. It has a common difference. That means that if we turn around, if we look at them, if we look at a pattern here, they have a common difference, something that's constantly being added to it to find it. So an example, if we looked at the series and we had 2, 5, 8, 11, we could keep going with the series. Obviously, if you look at these, what's the jump between each one of these? What's the jump between them from 2 to 5? Well, that's a plus 3. From 5 to 8, that's a plus 3. From 8 to 11, that's a plus 3. And remember, if you want to find the common difference, what do? We take the second number in the sequence, which is 5, and we subtract the number before it. It comes up with 3. We take the third number in the sequence, which is 8, subtract the second, which is 5, come up with 3. We should come up with a common number every time. So that is an arithmetic sequence. Okay? Now, in an arithmetic sequence, sometimes we're not looking for just the next term. Sometimes we're looking for a number that's further on down the line. Maybe, we've got the first 4 listed. Maybe we want the 14th term or the 81st term. So there's a formula for us for finding that term, okay, for finding that nth number term. So n is simply going to be the number in the series that we're looking for, okay? So we're going to use n to represent that number in the series. So we're looking for the a to the nth term. So we're looking for whatever that is, the nth term in this sequence, in this arithmetic sequence. So in order to find that, the formula is a to the first. That is simply the first number in our series, the first number in our sequence, which for us right now, this a to the 1 is 2. It's the first number in the series. So we take that, and then we're going to add to that n minus 1. Remember, n is the number in our series, times d, times that common difference. So, for example here, if we were looking at, I don't know, say the fifth number, or let's go the fifth number in the series. We could find it easily. We know it's going to be 14, but we could use this formula. A to the first, which is 2. So we're going to take 2 plus n minus 1. Well, we want to find the fifth number in the series. So 5 minus 1, which I know it's 4 and you know it's 4. We're just going to humor me right now. And we know that the formula is that the common difference right now is 3. So if we did this, 5 minus 1 is 4. 4 times 3, 12. 12 plus 2 is 14. Well, guess what? If we went up here and we added 3, what's the next number in the series? 14. So this is a formula that we can use, that we're going to use in any arithmetic sequence. So there's that formula. Make sure you write it down. Get it someplace where you won't forget it. Highlight it. Box it in. There is the formula for finding the nth number in a series. That is the formula for finding any number in an arithmetic sequence. Well, guess what? If there's one for an arithmetic, yes, you guessed it, there has to be one for a geometric. So looking at geometric series, remember, a geometric series, this is one with repeated multiplication. Whoa, which Maxwell can't spell right now. There we go. Let's try this again. It's repeated multiplication. So we've looked at these repeated multiplication. This is simply a series where something is repeated, multiplied. So let's start with, let's start with 3 this time in our series. And so the next number in our series happens to be 9, 27, 81. And remember, if we're looking for this, to find it, if it's a geometric, if it's repeating multiplication, we take the second term, 9, divide by the first. 9 divided by 3 is 3. We could take the third, which is 27, divide by the second, which is 9. We get 3. So notice that this one repeatedly, if we're looking at the pattern, what are we doing? We're timesing 3, times 3, times 3. So we could repeat this pattern, and we say that this common number that we're dealing with here is a common ratio. Remember that term, common ratio. For an arithmetic sequence, it's a common difference. For a geometric series, it is a common ratio. So now, just like in an arithmetic sequence, there was that special formula that we said we could use in an arithmetic, there is one to use as well in a geometric series, okay? So if we're trying to find the nth number in the series, okay, and n is just the number in the series. The number in the series that we're looking for, whether that's the 5th number in the series, the 10th number, the 81st number, whatever it is, okay? So when we look at this one, our formula to this one, it is if we're trying to find a to the nth, we're trying to find the nth number in the series. Here again, we're going to start with a to the first. And remember from arithmetic, a to the 1, that is simply the first number in our series, which right now happens to be 3. So a to the first, so we're going to take a to the first times r. R is our common ratio. Common ratio, that's r. That's our common ratio, raised to the n minus 1 power. Okay, so this is where exponents come in, raising it to the n minus 1 power. So if we're looking for, obviously we could keep this pattern here. We know that the next number in the series times 3, we could turn around and we could do this. We know what the next number of our series is. Okay, we know we can multiply this one by 3 and we would find that it is 243. Well, what happens if we didn't know that? What if we only knew the first 2 numbers in the series? Let's say we're looking for the 4th number in the series. So if we're looking for a to the 4th, we're looking for the 4th number, which we know that the 4th term is 81. So we could use this formula. We use a to the first number in the series, which is 3. So 3 times r, our common ratio. We know our r here is 3, raised to the n minus 1 power. Well, we're looking for the 4th term, so it's going to be raised to the 4 minus 1 power. So what's 4 minus 1? Well, that's 3. So 3 to the 3rd power. So we've got now, this is that first 3, times 3 to the 3rd power. Well, 3 to the 3rd, that means 3 times 3 times 3. Well, that's 81. And 81 times 3 is 243. So here again, same thing we've already found. So here is that formula. Get this one, write it down, put it someplace special, commit it to memory. This is the formula for finding the nth number in a geometric series. Okay? So let's practice. Okay? Looking at this one. Find the 9th term in this sequence, in this series. Well, first of all, we've got to figure out, is this arithmetic, is it geometric? So looking at them, negative 12, negative 8, negative 4, 0. Okay. Well, it's not dividing by 2, obviously, so that's not it. Looks like it's some sort of arithmetic, so let's check. Arithmetic. I would take negative 8, subtract negative 12, and I get a positive 4. Let's check with that angle. Let's go negative 4, subtract negative 8. What do I get? Positive 4. Okay, so I have a common difference. I know that the common difference is 4. So since I have a common difference, this is an arithmetic sequence. Okay, so arithmetic sequence. So that means I'm using the formula a to the n is equal to a to the first plus n minus 1 times our common difference. Okay, so what are we looking for? 9th term in this series. 9th term. Let me change colors real quick. So it means I'm looking for a to the 9th, the 9th term. So a to the first number in our series, First number, hey, that's a negative 12. So we've got negative 12 plus n. N is the number in our number in our series. We're trying to find the ninth one. 9 minus 1 times our common difference. What's our common difference? We found it. It's 4. So here we go. So a to the ninth is going to be negative 12 plus 9 minus 1. Well, that's 8. 8 times 4 is 32. So that means that a to the ninth, our ninth term in our series, is 32 plus a negative 12, or 32 minus 12. So our ninth term in the series is 20. There we go. We found the ninth term in our series. So our ninth term in our series is 20, using that formula. Okay? Yeah, some of you are going, well, yeah, but I could just keep adding 4 and get to it in the ninth. Well, that's fine as long as it's the ninth. But what happened if it was the 90th term? So this would definitely save you some time. And it's a whole lot easier to use that. So let's look at our next one. Ooh, negative 6, 12, negative 24, 48. Well, obviously it's not arithmetic because these signs are changing from a negative to a positive, negative to positive. That's no way. So it's got to be geometric. So let's check. Let's take the second term, 12, divide by the first term, negative 6. See what we get. Hey, I got a negative 2. Now let's try it again. So let's take the next term, negative 24, divide by the second term, which is 12. What do I get? Negative 2. Okay, so the common ratio then is negative 2. Common ratio is negative 2. So this is definitely geometric. So we know we're going to use that formula for geometric. So remember that formula we wrote down just a minute ago. A to the nth is equal to a to the first times r raised to the n minus 1 power. Okay, so we're looking for the ninth term. So our n is 9. So a to the ninth is equal to a to the first. A to the first is our first number in our sequence, in our series, which is negative 6 times r, our common ratio, which we said is negative 2. So we've got negative 2 raised to the power of n minus 1. Well, n is 9, so 9 minus 1. Change colors here real quick. Okay, so a to the ninth is equal to negative 6 times negative 2 raised to the n minus 1, which is 8. Ooh, well, this is going to get quite interesting. So we've got to take negative 2 and raise it to the 8th power. So negative 2 times 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 negative 2. Well, that's going to be fun. Might be a good time to pull a calculator out right now. Use your phone. So we've got negative 6. I can tell you this, because it's raised to an even power, I know the answer is going to be positive. So that's a good thing. It's not going to be negative. And if you raise it to the 8th power, I happen to know already that it's going to be 256. Okay? So, what is our a to the 9th power? Well, we're simply going to do negative 6 times 256. So a to the 9th is negative 6 times 256, which is actually a negative 1,536. So what is the ninth term of the series? Negative 1,536. Well, I don't know about you, but I'm glad I had a formula. I would definitely not want to keep multiplying by negative 2 9 times and to get to those numbers. So it was big enough on its own. So here you go. Here is the formula for finding the nth term in a sequence, in a series, depending whether it's arithmetic or geometric. So you need to know these two formulas. These are going to be important ones for you. You will see them on a quiz. You will see them on the test. So if you've got any questions, jot them down, bring them back to class, take them to tutoring with you. If not, I will see you in class tomorrow.